How's it going? So today's lesson, we're actually gonna go over solving systems of equations by graphing. So we got 3 questions that we gotta answer. Make sure that you follow along with the notes. Cool. Now, what is a system of equations? So the definition of a system is a set of equations that you deal with all together. Okay, let me simplify that a little bit. Basically, instead of graphing one equation, you're gonna be graphing two. That is really what a system of equations is. So let's go ahead and get started. Now, you're gonna notice right away that my 2 equations are actually in standard form. Okay, remember that we don't really like the standard form. So we're gonna go ahead and transform them into y equals mx plus b. So the slope-intercept form. All right. Let's go ahead and do that real quick. So before we can graph them, we got to make sure that we do this first. So I got 2x plus y equals 4. And then I got x minus 3y equals 9. I'm going to go ahead and work with one of each separately. So as always, try to get rid of the x's first. So I'm going to minus 2x on both sides. That's going to equal 0. And I'm going to be left with y equals negative 2x plus 4. All right, now there's no coefficient in front of the y. There's no number in front of the y, which means I don't really need to divide anything. So technically this is my answer. Now I am going to put a 1 under it because I want my slope to be in the form of rise over run. But so far, that's my first equation. All right, for the second one, same process. The first thing I want to get rid of is my x, so I'm going to go ahead and minus an x to both sides. That's going to equal 0, and I'm going to bring all of that down, which means that now I have negative 3y equals negative x plus 9. All right, now I do have a negative 3 in front of the y, which means that I got to get rid of it. Now, to do that, we're going to go ahead and divide everything by negative 3. And to make things a little bit easier, I'm going to put a 1 in front of the x because there's no number, and that usually confuses people. Let's go ahead and simplify this. I know that's going to be 1, so I'm going to be left with y equals, now 1 over 3 is going to give you a decimal. Remember that we don't really like decimals, so we're just going to keep it as a fraction, 1 over 3. But we do have a negative divided by a negative, which means it's going to turn all of that into a positive. So I'm going to be left with 1 over 3x. I can simplify 9 divided by 3. That's going to equal to negative 3. And there's my second equation. So now I can go ahead and graph them both. I'm going to graph the first one with blue, and I'm going to graph the second one with red. All right? So, because now they're in the format of y equals mx plus b, I know that this is my m, which is my slope, and this is my b, which is my y-intercept. Cool. Well, my y-intercept is going to be 4, so I'm going to start from the middle, and I'm going to go up 4. That's my starting point. My slope is going to be negative 2 over 1, which means that instead of going up, I'm actually going to go down. So I'm going to go down 2 over 1. And there's my next point. Now, usually I tell you guys 2-3 points is enough. When it comes to a system, I want to be as accurate as I can. So I'm going to continue to find more points. So starting from my second point, I'm going to use my slope again. Down 2 over 1. And then again, down 2 over 1. And one more time, down 2 over 1. And now I have a very accurate graph. Perfect. Let's go ahead and graph the second one. So the second one, same thing. That is my slope. That is my y-intercept. My y-intercept is negative 3, which means my starting point. I'm starting from the middle, and I'm going to go down negative 3. So that's my starting point, my y-intercept. My slope in this case is positive, which means that now I'm going to be rising. And I'm going to be rising by 1 and running by 3. So starting from that point, I'm going to go up 1 and then 3. I can't really make another point, but I can do it in reverse. So I can actually do the reverse of up 1 over 3, which would be down 1, left 3. And for this equation, that's as many points as I can find. So I can go ahead and create my lines. Okay, so this is what we call a system of equations. Now, when it comes to a system of equations, we also got to have an answer. And we call that answer a solution, which brings us to the second question. What is the solution to the system of equations? So when I refer to the solution, I'm asking for the answer. Now, what is the answer going to look like? So the solution to the system of equations is the intersection. Basically, I want to know at which point do they intersect. So at which point do they touch each other? Which in this case would be right there. Now, what point is that? Well, that would be 3 comma negative 2, which means that your solution is 3 comma negative 2, which means that is your answer. Okay? Take a quick minute, let that, go into your head, digest it, and, try to make sure that it makes sense. All right, to finish off the notes, when it comes to systems of equations, we're actually going to have 3 different types of solutions. So 3 different types of answers. Let's take a look at the first one. If the lines intersect, so if the lines touch in one spot, just like this one, right there, we're going to call that a one solution. All right. Now, if the lines overlap, meaning if they're on top of each other, just like this example, we're going to call that a infinite solutions. All right. And the last one, if the lines never intersect, so meaning if they never touch each other, just like this one, notice that there's no intersection, we're going to call this a no solution. All right, so those are the 3 different types of solutions that you're going to see when it comes to a system of equations. Now, what I want you to do is I want you to go ahead and do those 3 problems by yourself, and let me know which one is the one solution, the no solution, and infinite many solutions. Good luck.